Okay, I'm sharing. Why it's showing is
So we
disabled?
can
Host disable participant screen.
one sec. Yeah. So you can share your screen and discuss your queries with your exercise.
Okay, so here, can you see my PDF
Yes.
page? Okay,
Yes.
so here they are asking to, create report for customer ID. Here is the result. My
Mm,
question is, they asked here, as well as the customer age as of this date.
mm,
And here, the customer's name displays as last name, comma, first name, right?
mm,
So
mm.
for that, do I need to see, I get little help in, see here. So what I did first, this is the title, select customer ID. Actually, I copied this from solution, but I want to ask this. What is Z7 dot?
It's leading zeros,
Oh, yeah.
leading zero with the width of 7.
Okay. And here, see, just a second. Okay. Here they are asking the customer's name displayed as last name, comma, first name. Okay.
Mm,
So what is customer name? This is the column name, right? Customer
mm,
underscore name. So
mm.
am I doing right way? Customer underscore name is equal to,
No, in SQL, we never use assignment statement. In your select statement itself, you have to simply write this and give it as label. Remove that. Yes, that's it. You've already given that label, right? Last name, comma, first name. So that label, it
yes.
will come.
Okay. And this one also I could not understand, so I got it from
This
solution.
is,
This
yeah, this
this one.
is like you are calculating age, right? So it's like your,
Yes, yes.
what we can say, calculated or assignment or expression where you are asking SAS that this is on this date and whatever is the column, which is the birth date, as
Hmm.
per the birth date on this date, what would be the age? Hence, you are dividing with the number of days.
Yes. So here, this is solution actually.
Hmm.
Okay, so my question is, why they creating new column name as name? Do
It's
do we really
because
need
yes,
to?
it's giving a column name because as your report is telling the column name should be name, right?
Hmm. Customer underscore name, right?
Hmm. So that is the
So
existing
customer's
column.
name displays
See,
as
no, look at the result, Pragati.
here.
It's
Hmm.
last space name, comma, first space name. This is the column which is getting created, right?
Yes, but I gave label already, so anyways it
It's
will
okay,
come.
no problem.
That's
So
I'm
label
saying.
will
I
come.
already
Give me
gave
the
label
control.
here, right? Okay, okay,
I've asked the control, okay? One
okay.
sec. So this is the label, fine. So the label will already come, right? This is the
Hmm.
column. You're creating a column. It's like you're creating a proper column, and on that column, you're giving this as a label. So label will be there on the report. Original name will be name.
When we are using as, that means it is creating new
It's a
column.
Yes,
column. It's
that
a
I got it.
column.
That I got it. Ki as we are creating a new column, which is name, and we are giving label last name, comma, first name.
Yes.
Right?
Yes.
Okay.
That is
So,
the reason why your result is coming with a label as an output. So in case if we execute this,
hmm, everything I got it except these two things. Otherwise,
okay, so there is an error.
oh,
Orion
because
library is not assigned. All right. So let's assign it for SQL. See, it's coming as a label.
Hmm.
Are you getting the difference? So in case now, if you do not give this label,
Yeah, that I know, that I got it, why we are
okay,
giving this label.
all
And
right.
here
So
also,
this will be the column. Yeah, tell me 1 second.
okay, it's taking time from my side.
No,
Name. Oh, yeah, because we are creating a new column as a name.
correct. Got it now? Understood?
Yes. And another one more question.
Hmm.
See, here they what they said, create a report that displays customer ID. Okay, this customer ID.
Hmm.
But do I need to give one another they because they gave label also as same name.
Yes,
See?
yes, yes. So it's a name. See, there is no underscore, there is a space. So, as per your naming convention in SAS, we cannot use special signs like space or star or dash. Hyphen is allowed, right? Hence,
Hmm.
their original column name was coming with hyphen, but now they want the report with space. So, space is available in
Oh
SAS
yeah,
column
it's a
name
different.
only with label. Hence, you are giving this label.
Correct. I got it. Oh, I could not actually recognize that one. There is
Okay.
just no underscore. Okay, got it.
All right.
Yes. And the
All right.
first, this is level 1 and level 2. I did it without help of solution. That
Great.
was
Good
easy.
to hear. Good to hear.
Yeah. Okay, I stop sharing my
Yes.
screen.
Okay, sorry for that disturbance. There was some siren going on. It's okay, no problem. Let's move on with our new lesson. The lesson is all about joins. So we have lesson 4, which is chapter 4, SQL Joins, where we have 4 topics here: introduction to SQL Joins, inner joins, outer joins, and complex joins. Okay, so let's
Did we,
understand what.
Ashwini,
Yes,
did we
yes,
finish our last
yes,
chapter?
yes, we did finish it.
Okay. Okay.
Okay, yeah. So let's start with SQL joins. We have introduction, inner join, outer join, and complex SQL join. So with this, we let's understand what joins are first, and then we'll move ahead with types of joins. Now, joins is possible in SQL when, as per your base SAS, when you have data scattered in various tables, you never have information always saved in one table. Whenever you'll be working in a live scenario, you are going to have data scattered in various tables. You need to put the information together and create a single table for our report generation, or you can directly create the report with SQL. So in that case, when you have data in 2 different tables, you need to join those tables on the basis of a common column or a information which is provided. And that is what we'll be looking as introduction to joins. And these are the types of joins. It's same like your merge. I hope you remember in data step you came across with merge.
Yeah.
Yes,
Yeah.
yes. So merging was we were merging on common column on the basis of the order of the rows, and therefore hence in your data step merge your data has to be pre-sorted, right? So that was the prerequisite with base SAS. But when you are working with joins, let's understand how the two tables are going to combine and what are the various types of joining options. So very first thing which you will be looking ahead is introduction to SQL joins. So we'll understand or we'll identify different ways to combine data horizontally. Remember, sideways join. It's the same thing like your data step merge where you were joining the tables sideways, that is on the basis of rows, correct? So common column and of course on the basis of common values on that column. Are you remembering? It was combining and creating a single row between the two table on a common column, right? I hope you remember. So same
Yes.
thing, we are going to combine the table horizontally, sideways from multiple tables, will distinguish between inner and outer joins, and will also understand what a Cartesian product is. So moving ahead, we'll understand the same thing through a business scenario. Now you have two tables called as customers and transactions. Now understand logically, or it's a very simple business scenario. When we have a customer data and when we have a transaction data, of course we know we are working with Orion data or Orion organization table, and in this table we know, or this organization, you are quite familiar that this organization is having information about your sale of your sports goods, correct? And the sale is all we have is the information which is between the customers, the sales representative people who are handling the customers or who are doing the sales, or the type of sale, whether it is a catalog sale, whether it is a direct store sale, or it is an internet sale, correct? So this is the data, and at the same time you have the information about the customer doing the transactions or performing the goods from the stores or via internet. Hence we have the data for customers, and we also have the data of the customers performing the transaction with the organization, correct? So when we have these two tables of transaction and customer, so of course the information with customer data is going to be their customer ID, the sale or the purchase which they have done with us, or general information of customer name, address, right? And when it comes to transaction, of course we are going to have customers, their information, that is the customer ID who is performing the transaction with the organization, and the transaction detail. So what is common in them? Customer ID. Got it? Are you getting it what I'm trying to tell you? So whenever
Yes.
you are going to join a specific information from scattered tables, you need to combine on the basis of common table, right? So as per management here, management has requested multiple reports. You have to understand how to combine the data from the tables to complete this request. So you have two tables, customer and transaction, and the result is we have to generate report out of these two tables. Now look at this information. Look at the tables carefully. It's self-explanatory. I've already discussed. You will also understand. Look at it. So what do you understand from this two table? Customers
ID
and
is the
transactions.
common table. ID is the common.
ID is a common, absolutely.
Yeah.
So depending on the common value also, see here you have a same value 102, 102. So this value will be the common, and you will get a single row when you join this information, correct? So you have matches, you have non-matches as well, because in this table you have 101, 104. This table does not have 101, 104, but it has 103, 105, which is not in this table. Hence we have matches as well as non-matches. Correct? Now, you are exploring this table. Now, what they are telling here is the customer data table is representative of customer dimension table. So when we said customer dimension, that means general information of your customer, that is customer name, ID, address, phone number, birth date. Is it a prime customer? So what is a customer type? In which age group that customer falls? So this is your customer dimension data. So there would be additional columns with data about our customers, including address, age, and so on. Whereas transactions table is representative of a fact table, there would be columns holding all key columns like product ID, employee ID, and so on. Why? Because if there is a transaction table, that means which salesperson has entertained that particular customer. So you'll have sale, you'll have product ID, what the product has been purchased, which employee is interacting with that customer, so employee ID, and of course customer ID, correct? So combining data from multiple tables, we are going to use SQL join as a concept. So we'll be using SQL joins to combine tables horizontally. The concept is horizontal join, that is sideways. So requesting a join involves matching data from one row in one table with the corresponding row in a second table. That is what it's telling. From one table, one row which is common in the corresponding table with the second row. So this is common, correct? So that's what it's telling. So matching is typically performed on one or more columns in two tables. So you can match the two tables not only on a single or two common columns, but also on more than two column commons also. All right. Okay. So before moving into it, you have a poll. Which of these data step statements is used to combine tables horizontally in your base SAS? Yes.
Merge.
Absolutely correct. We have already discussed before starting your SQL. So whenever we'll be combining the two tables horizontally with your data step, we used merge statement. Absolutely. Yes. So these are the types of joins when it comes with SQL language. So this is called inner join. So look at here. This is one table. This is another table. So there is something common in them. So only on this values you are going to select the rows. So that is inner join, matching rows. All right, Pragati, Meena.
Yes.
Yeah.
Moving ahead, when you are joining tables, there could be matches as well as non-matches. So it's telling when you are joining two tables, you are not only selecting the common rows, but also the non-matches. It's called left join. All right, so it will take non-matches from the first table, that is this table which is aligned left side, okay, which is called as left join. This would be inner, that means common rows, as well as non-matching from the right table is called a right join. And when you are selecting both matches, non-matches, and from all the combination, all the rows from both the tables is called as full join. Is this diagram clear?
Yeah.
All right.
Yeah.
Okay. So let's see how SQL works. So before working with joins, you'll have to understand a very single thing, which is a Cartesian product. Not a single, but most important and basic information about SQL joins. Whenever you are performing joins, we need to understand what Cartesian product is. So before moving into Cartesian product, I'll show you this demo. Okay. So this is my SQL joining. All right, so my library is ready. So let's move with lesson 4 with demo 01.
Ashwini, we can see your PDF only.
One sec. Thank you. So hope you can see now
Yes.
my studio.
Yeah.
Okay, so while sharing, I just selected PDF. Sorry, my PPT. That's why you were saying only that. So let's work with demo D01. Here it is. D01. Do you see anywhere?
Yeah.
Chapter 4, right?
104D01.
So
Go down.
let me,
D1
it's
to.
okay. Oh, it's okay, no problem. All right. What is doing, I'm doing is this is a ready code where they are creating table. I'll explain this code also later on. So you have two tables with us now. Our table is customer and transaction. Okay, so what I'm going to do is I'm going to simply write proc SQL select star, that is all the columns from, I give the table name as customer, comma, my second column is table is transaction. So in SQL, whenever you write more than one table in from clause, you also need to give a comma to separate the two columns or two tables. Okay, so this is work data, work column, hence the, okay, so this is customers, this is transactions, and I simply write fine. But before moving into this, let's understand your output table. So this is your customers table, which has three rows, ID and name. Okay. Moving into transaction table, you have again 3 rows: ID, action, amount. Okay. So come into code and let's see. You are just simply naming the columns or tables, sorry, separated by comma, and you are selecting all the columns to be
Columns.
queried. Yes, from both the tables. Look at the output. Okay. So before moving into output, first and foremost, let's understand the number of rows. Self-explanatory self-understanding is very important. Look at the output carefully and tell me what is the difference.
Yeah, two tables combined together.
And in
But
first table there is ID and name, and in second table there is ID action.
the action and amount, what?
So
Yeah,
that
as
is fine. Look at the rows.
ID, it's repeating, right? That value 101.
Look at the number
ID
of rows. Look at
Yeah.
the number of
9.
rows.
It's 9. Yeah.
So ideally we know it should take common rows, correct? Common values. But it's resulting 9 rows, correct? Let's
Yeah.
check your log. So your log has been showing you that this was your SQL code and this is the note. Execution of this query involves performing one or more Cartesian product joins that cannot be optimized. So what is this Cartesian product? Okay. So what does you mean, or what does we mean by the Cartesian product is? So you know that there are 3 rows in each table, correct?
Yeah.
So every row from your customer table is combining with every row on your transaction table. Hence, the output which you see is a result which is Cartesian product. So 3 rows from first table into 3 rows into your second table, total row is 9. Are you getting it now? Every row from your first table is combining with your first row of your transaction.
Oh, got it.
First row from your customer table is combining with the second row of your transaction. First row of your customer is combining with the third row of your transaction. Then second row of customer with all the 3 rows from transaction. Then third row of your customer is combining with all the 3 rows of transaction. This is called as Cartesian product, where every row from your first table is combining with your second table. It's called as a Cartesian product, and that is what it's the default behavior of your SQL. When you are writing 2 tables in your from clause, default nature at the backend is SAS or SQL is going to give you the Cartesian product. Got it? Now, if you want to, or you should optimize this. Optimize means you have to give instructions to SAS that it is going to perform a Cartesian, which is a default nature, but need to give instructions in such a way that it will give you a correct result. So now what is common in both the tables? Which column is common?
102.
ID
Yeah.
is common.
Yeah,
Column.
yeah. Column,
So
column,
we are
yes.
going to give the instructions to SAS telling where customer dot
Customers.
ID. We know it's customer.id. Customer.id from your ID table is equal to or is common with your transactions.
Customer.id
Got it?
is equal to.
So we know this is a table name and this is a column name. This is a table name. This is a column name. So we are telling ID is a common table, so common column from this 2 table, and join these 2 tables on the basis of common column. So now understand. I execute this proc SQL. So what I get?
Common.
Common ID.
Only the common row, which
Yeah.
is matching row. And when you check your log, what you see? Do you see any note about Cartesian product message?
No.
No.
No. So this is what you have optimized. And in case now in your output in the result, you are saying that ID is the common column, correct? Which is
Hmm.
repeating. So if you want only this column, so what you can ask SAS, instead of writing select all columns, you can ask SAS to select custom ID from either of the tables. So you can write customer.id, comma name, comma action, comma account, correct? Right? Other columns, action, amount. Yes, it's
Name.
amount, right? So
Okay.
name is there. Now execute. Got it now? So this result is similar like your base SAS data step merge when we write in equal to dataset option to select only matching rows. Got it?
But Ashwini, for second table, ID is same, that value 102, but the name was different, I think.
We don't have name column in transaction table. We have
Oh,
name column only in customer table. It's joining on the basis of ID column. So here
okay. So
the ID and
102
name. So
bank
102 blank and transaction you have 102. Its action is
action
purchase and
purchase.
amount
Okay,
is
okay.
this. So
Got
your
it.
result which you are getting is common row,
Hmm.
which is horizontal join.
Yeah, name, action, and amount. Okay.
Got it? So
Hmm.
basically, what is a Cartesian product? So a query that lists multiple tables in your from clause without a where clause produces all possible combinations of rows from all the tables. This results it called as Cartesian product. Understood now? So to understand how SQL processes join, it is helpful to understand the concept of Cartesian product, which we have already seen. All right.
Yeah.
Okay. So this is how the Cartesian product is working. See, first row from your first table is combining with first row from the second table, first row with the second row from the second table, first row from the third row from your second table. Then again second row with the first row, second row, third row of your second table. Then the last row from first table combining with first, second and last row. So out of all this, 3 into 3 gives you the result as 9, which is a Cartesian product. Understood?
Hmm.
Yes or no?
Yes, yes, yes.
Okay. See, the Cartesian product is rarely the desired result. Of course, we never request to have a Cartesian result as an output. We need to accordingly give the instructions so that it will select only desired rows, right? But by default, at the base, at the backend, whenever you specify two or more than two tables in your from clause, default behavior, default nature of SQL is to give you the Cartesian product. All right.
Okay.
So we know this is a non-match. This is non with matches and non-matches. So total it gives you a 9 rows, right? So this is how it works. 3 into 3, 9. And in case like this, it goes on. And of course, you get this note in your log. So it's a default behavior. So the number of rows in Cartesian product is the product of the number of rows in your contributing tables. So in case your tables are contributing 1000 rows each, it will give you so many rows. If your table contributes with 100,000 rows each, it will give you so many rows. But this will affect the processing at the back end of your system. Your system will go slow. Hence, to avoid a Cartesian product, it's always mandatory to tell SAS on what basis you are joining the table. So that is our where clause was telling us that we are telling SAS that IDs is common. Hence it joined on the basis of ID and gave you only the common rows. Got it now?
Yeah, it
Yes.
save the system time and
Yes, it will affect your resources. And that is why very important statement they had mentioned earlier was this. A query that lists multiple tables in the from clause without a where clause produces all possible combinations of rows from all the tables. And this result is called as Cartesian product. All right, this is very important. where clause. Okay,
Yeah.
understood? So
Yeah.
this was all about our Cartesian product. Okay, answer this question now. How many rows and columns are returned from this query? Now, customer 2, how many rows you see? 5 rows. Transaction 2, you have 4 rows. So what will be the result if you simply use this query?
20.
20.
20? Okay, right. So this is what you see the output.
You have to multiply, right?
It gets multiplied. We are not doing
Yeah.
it. SAS or SQL is doing it. All right. Hence,
Mm.
to avoid this, we are going to restrict this rows to be generating a Cartesian product with a joining criteria. All right. So that's what just an introduction to SQL joins. Now let's get introduced to the types of joins, which you have already got introduced. We have got introduced to inner joins and outer joins. Outer joins, if you remember, you had seen there are 3 types of outer joins. So what are the 3 types of outer joins you have seen earlier? Yes. What was the 3 types of
Left,
joins you said?
left, full and right. Yeah.
Absolutely, left, full, and right. Okay, so these are the types of your outer join. This is their inner join. So let's see
Mm.
this in detail. All right, so let's understand inner join. Objectives: join 2 or more tables on matching columns. Qualify column names to identify specific columns. Use a table alias to simplify the SQL code. Join 2 tables with alternative join syntax. So this is what it's telling about inner join. That is, we'll be selecting only matching rows. So first report which we have to generate is via inner join. Management has requested a report showing all valid order information. So this is valid. That means customer and their transaction. So currently we have only common row from it is one customer, which is common in both the tables. Okay, so this is inner join. So how do we create this report? Let's get introduced to the syntax. So customer comma transaction, where customer ID, that is ID from customer table, is equal to ID from transaction table, and you get this output. So this is your select clause, where now where is not only using as a joining condition, but you can also use where to subset your query results also. So where can be used in 2 ways. Whenever you use joinings of 2 tables, where can be used as a joining criteria as well as subsetting your rows as well for your query result. Are you getting this? Yes.
Yeah.
Ideally, you know what where does, right? Where is to
Subset.
subset the query result.
Yeah.
But
Mm.
here, where is also playing a role which gives the
Join.
criteria of join. Telling ID from customer is same as ID from transaction. So that's what it's telling. You can give your other clauses also, you get the output. Because you have written asterisk sign, you get all the columns from both the tables. You know what asterisk does. Asterisk simply will select columns from customer and columns from transaction. SAS does not know that ID is same here. It's just taking ID name from customer, ID action amount from transaction. That's why it's giving you all the columns, right? So this is what the question is. Why are there 2 ID columns in result? I've already discussed. Give me, so you can tell me why we are getting this.
Because it's taking as both from both tables, like ID from
Yes, because
customers and from transaction.
absolutely, it's because your query itself you had specified asterisk in select.
Asterisks, yeah.
So
Yeah.
asterisk indicates select all columns. That is why it's selecting columns from customer and columns from transaction.
And
That's why you're getting it like this. That's what it's telling. Read it.
yes, got it.
Understood? Okay.
Yeah.
So this is what you give the where criteria, which is joining your tables on the joining criteria. So you specify table name dot column name is same with table name with column name from both the tables, that ID is common. So you cannot write ID equal to ID. Okay. So let's understand if I give that way. Why we cannot write ID equal to ID? Any idea?
Because we are taking ID from two different tables.
Tables, yeah.
By the table name, which table it is.
So in case if I give it in this way, what is it? Understand what it's trying to tell. It's an error.
Right.
Because it's SAS is not
Column ID is more than one table. Yeah,
So it's not understanding what ID is, because ID from both the side of equal to sign is say same name. So it's not, it's telling ambiguous reference. Column ID is in more than one table, because this ID is not coming from one table. It's coming from customers also, and it's coming in transaction also. Same goes here. Hence it's giving you the error. Understood now? So it's telling SQL set option, or you can always, in this case, if you are not aware whether it will give you error or whether it will execute, just go ahead and use no execution option and check for its syntax check. Got it now? That's what it's giving you the note. I hope you remember no execution is one of your
yeah,
SQL option to check your
yeah,
syntax errors. Right. Now we know that we have seen this. So let's correct it. Right? So the same thing. So it's very important that you need to specify table name with a column telling which table and its column is similar with the second table and its column. Okay, now a poll. So it's telling you to run a program with activity A02 and review the result. So open this activity A02. So before moving with this activity, just open this code and I'll tell you what to do before this code. It's activity A02. Do we have this activity? All right. So it's telling no, there is no this activity. All right. So don't worry. So it's simple. The same thing which I have discussed, right? We don't have this activity on your code. Meena Pragati.
Yeah.
no, yeah, we
Okay. So
can't
it's
even
the
find.
same code.
Yeah.
Yeah. So it's the same code. And this is what it's giving us. So what message we got it? So message we got ambiguous reference of column ID is in more than one table, right? So it stopped the processing because of error. Okay, so now let's complete the code for report one. So report one, same thing. Now you select from any one of the table ID. So you are referencing it as customer.id in a select clause, name, comma, action, comma, amount. So the same order it will follow in your output and you get only the matching rows. Now one thing, in one of your earlier program, I had introduced you this SQL. That time
Uh,
I had explained you.
Ashwini, I have
Yeah.
one question. Like here, when we are selecting ID and name from customers, right? But action and amount column is from transaction.
Hmm.
So we don't need to give that in select option.
Because we have given a name, action, amount. Now no need of giving table name, because see,
Hmm.
it's very common when we look into this table itself. SAS understand that you don't have action, you don't have amount in your customer table, so there is no need of giving customer dot name. And because name column is not in transaction, so no need of writing transaction dot action, dot amount, because when it is into compilation phase, it checks for the columns, right? Only ID was common.
Common. Okay.
That's why. Got
Okay.
it?
Hmm.
Okay. So now, instead of writing the whole table name into your reference, we give the alias of your table, right? We write as C for customer and we can write as T for transaction. So instead of writing customer.id, I can write C.id. And instead of writing transaction.id, I write T.id. Same goes when referencing in a select clause also. So this is the best part of representing your query. So it's the same result. So instead of every, now it was a very simple small table, that's why you were writing. But when you are working in a live scenario, your table names would be with reference a lot many letters, or too huge table also sometimes. So in that case, do not make use of this. Just make use of an alias of your table. So you are naming this table as C in your from class, and whenever you are specifying your from clause with the table, you name it as T. So that's why C.id here also, and in your joining criteria of where also you give the same thing. Got it?
Yes.
So same thing, see alias. So table alias is temporary alternative name for a table. You can make the query easier to read by using table aliases. You give the join conditions. So as keyword is optional in your table alias syntax. In case if you do not want to give alias, no need of writing. Hence it's giving into optional as an optional brackets. This is how it's telling. All right. Okay. So this was an inner join. So this result of inner join is same like your data step, selecting common rows with in equal to dataset option. Observe this code carefully. So prerequisite with merge and data is your data needs to be sorted by ID. Very important.
Yeah, in SQL we don't have to sort it.
Yes, in SQL it's not required. So before going here, I need to sort it. First thing is I'll write proc sort data equal to customers. I'm not creating an output data because it's a table which I'm creating. Okay, so I can re-execute this table. Okay, fine. Hence you can all, I will explain you later on when we are creating our table by doing SQL. We sort by ID, run. Then again proc sort data equal to
Transactions.
all right. By I missed out by ID. Transaction, maybe the spell is to be checked out. All right, so now they are sorted, and now I'll be using a data step merge. So this result of your data step and your proc SQL, let's check into output. So this is your data step output with proc print, and this is your SQL output. See, result is same, right?
Yeah.
See your data step merge, it's using in equal to dataset option, and you are using which is common rows, select only those with this if criteria. The result is inner join, or you say matching rows from both the tables. All right.
Mm. So customer ID.
All right. So now look at here. So it's telling inner join versus data step merge. So proc SQL inner join and data step merge, match merge will not always return the same results. Why? Because look at this code or look at this tables carefully. Here for same ID you have two rows. Same ID you have two rows. But for this two rows you have one row here. or two rows here. So it will be one to many types of join or match merging. But when it comes to SQL join, it will be a different result altogether. Understand? Understand what will happen if you write proc SQL and if you write data step. Just look at the columns carefully, look at the rows carefully, and understand your data step merge. Understand your SQL at the back end, it's a Cartesian product. Just think, visualize, and then I'll go ahead with this slide. Understood what is happening and what they are telling? SQL inner joins and data step merge will not always give you the same results. Why? So understand this. Okay, this is your data step merge. Okay, now before moving into it, let me tell you that where this data is. So see, you have this table code called as 4D00A and 4D00B. So 4D00A code was all about you are creating two tables, which was customers and transactions. Whereas 00B is creating two tables called as customer 2 and transaction 2, which is the same tables which we have on our slides. Okay, fine. So moving ahead, I'll just show you the same thing. First and foremost, let's create these tables. Okay, these tables are created. So this is your data step merge. Fine. Before that, let's use the sorting process. Just copy this sort process. So this is customers 2. This is transactions 2. Okay, first is we need to sort and then we are merging it. Fine. Let's do this. Okay, I have an error. Is it customer? Customers 2. It's customer. Here itself in sorting we write S, which is not required. It's customer and this is transaction. Here it is. All right. Now it will give you the output. Okay, merge transaction 2. In equal to, in it should be in the bracket. All right. So merging has occurred. And this is the output. Now, before moving into output, let's work with SQL join. So I'll select the same thing of your SQL joins. So here is the name customer 2, right? Here is 2. All right. Let's check. First result is your proc print. Second is your SQL. Now, what is your data step merge result number of rows and what is your SQL number of rows? Now, why this? Tell me. What is happening at the back end? Understand and tell me.
In Proc SQL, it's repeating, right? Purchase return and 2 time purchase return.
Why? Why?
No idea.
It's because of Cartesian product. Default behavior is Cartesian product. So it will first, what will SQL do is, SQL will perform a Cartesian product, and after a Cartesian product, it will subset the rows on this. Getting it? That is why the
Yeah,
output
so
results, we have 4 rows, whereas here we have only 2 rows, which is matching. But here, of course, these are 2 rows which are matching, but this is the product of Cartesian product. So that is why it said that though your SQL inner join gives you matching rows, but it is same as your data step merge, but not always you will have the same result. Getting it? That is what they are trying to tell you.
okay.
So data step merge and SQL joins, though they return matching rows, but always you will not get the same result. Of course, in data step merge, it will select only matching rows. With SQL, first, the technique is it will perform a Cartesian product, and on that Cartesian product, it will subset the data on matching rows. And that is why the result we get is as this. Got it?
Mm,
Meena?
okay.
I
Yeah,
hope
Ashwini.
you people, yeah, are getting, yeah, understanding. Okay, so this is all about. So see how many rows
Ashwini,
or observations? Yes, yes.
good evening, Ashwini. Can't
Yeah.
we do anything for sort out that problem in
No,
Proc
it's not a
SQL?
problem. It's not a
Mm,
problem. That is a default behavior.
okay, okay.
Okay. So it's telling how many rows or observations it results from data step merge statement with this. So you know, we got
Data
with
step
the
2.
data step merge only 2 rows, right?
Mm,
So not always you'll get the same result. So what I will do is I'll give you this code A01. Of course, you have this already how to create these tables here. I'm not giving this, but I'll give you this so that you can just use it whenever you're practicing in your chat box. I will give you as activity for your SQL lesson 4 activity 01. Okay. So for this is the code. Fine. Whereas for your SQL lesson 4 activity 02, I'll be giving you this as a 00B code. Of course, this 00B, how to create this table, this code already you have it. Okay. I'm giving you this also. So you can work out. You can work out simultaneously.
workout means we have to copy and see like what results we are getting. Ashwini.
So let's move ahead. So that's what it's telling. Not always your data step merge and ProcSQL inner join results the same output. Okay. So let's compare both the steps. So key points on comparing is explicit sorting of data before join or merge in SQL not required. Agreed? Yes. Do you people agree?
Yeah.
Did we pre-sort our data? No.
No,
But when we are doing data step merge,
we
we
need to
require
sort.
pre-sort. Yes. Same name columns in merge or join expressions in SQL also it's not required. In case if it's ID or it is suppose customer ID, of course, whenever you are joining, you tell that customer ID or ID both are same, correct? But here with data step, the table names should be same, right? If
Hmm.
not, then you'll have to rename them if you remember. Equality in join or merge expression is not required with SQL, but here it says means sorting. Equality means the equal position of the rows, correct? In the same order. That's what it's telling equality. In merge, it's required, right? Either in
Hmm.
ascending in both the tables or descending in both the tables. Okay, so alternate syntax of your inner join. So between one table and second table you write a keyword inner join and you give your on as a criteria telling id is same in both the tables, and then you can write where, which gives you the expression to subset your rows. So alternate code of your inner join could be, I write proc sql, so it's proc sql select, let me take this as it is, fine. Now from clause as, so instead of comma, I use a keyword telling its inner join as a keyword with the second table. And instead of where, I use a keyword called as on criteria. That is a joining criteria telling c.id same as t.id. So if you check the result, it's the same. Got it? See, same result. Only here we had row option in used number, hence you get row. Here we do not write. Got it, people? So this is an alternate syntax of inner join. We use a keyword. Where was doing the same thing. Here you can add where to subset your rows later on. All right? Understood? So I can give you in your chat box. Check out. Same syntax which I've given you in your chat box. Okay. Okay. Now come to this slide. How many tables can be combined using following SQL syntax in your from clause? Any limitations of number of tables? That was the simple question is. What do you think?
No, we can combine.
No? Absolutely. The maximum number of tables which you can specify in your from clause is 256. Okay? Up to 256 tables can be joined with this syntax.
Okay.
All right. So the exercise I leave to you as a self-study. Let's move ahead with your outer joins. All right. Now understand this outer join. So we'll be learning or we'll see join two tables on matching columns and will include non-matching rows from one table. We'll join two tables on matching columns and include non-matching rows from both tables. And we'll compare outer joins and your data step merge results. So outer joins. So in outer joins, there are three types: left, right, full. Left means matching rows from both the tables and non-matches from your first table or it's called as a left table. It's called a left join. When you are selecting matching and non-matches from the right table or the second table, it's called a right join. And when you're selecting matching as well as non-matches from both the table, it's called as a full join. So outer joins include left, full, and right outer joins. Many tables can be referenced in outer joins. Many tables can be referenced in outer joins. The tables are processed two tables at a time. Very important point. Tables are processed two tables at a time. So you can retrieve both non-matches and matching rows using outer joins. So look at this. You have been asked for a report that displays all customers and any recent transactions that they have completed. All customers with recent transactions. Understand the question, understand the report carefully. You have been asked for a report that displays all customers and any recent transactions that they have completed. We know we have a table for customers, we have table for transactions, all customers and recent transaction. That means matching rows from transaction and customers. So that is transaction information, and all customers, that is all the rows which is non-matched with transaction. Hence all customers from your left table or your first table, you get the result as left join, which is matching as well as non-matching from the first table. Got it now? Understood? Very simple.
Yes.
Okay. So how do you achieve this report? So to get this report, very simple syntax. Instead of inner join, we are going to write left join. So simple thing. So which table SAS takes as a left table? The first table takes as the left table, and this becomes your right table. So this becomes the output of your left join. So it will select all the rows from customers
Mhm.
and matches from your transaction.
Transaction.
So hence you get a left join.
Okay.
Okay. The same thing if I copy with right,
Right
it's the same
join.
thing.
Mhm.
So with right, what you will get is you
All
will
the
want all the transactions with customer information, right? So let's see. All transactions left table, or sorry, right table, and you have only a customer, which is Kent, which has your information with
Okay.
transaction.
Mhm.
So this rows are blank. It's because your transaction does not have customer information from customer table. Hence, this is blank. So because you have all the right information or right table information, hence this is the right join. Got it?
Yeah.
And if you want a full join, or you call it as outer join, you write full join. Okay. So I'll read, or I'll select all the three joins. That become inner. So this is left, this is right, and this is full. Full with matchings, non-matching from first table, that is left, and non-matches from the right table, that is second table. All
Mhm.
right.
Yeah.
So let's understand from slide about your outer join. So that's what it's telling. So to get this outer join, see, they are using this column or outer join, left join. So it's telling they're selecting all the columns.
Okay.
So you can select from your table alias. Either you can write left, right, full join on your second table, and you're on as a joining criteria. So on clause specifies the join criteria in your outer joins. So see, left join on your, or your second table on c.id is equal to t.id. So this is what it's telling you, the left join result. Same goes if you're looking for right join, it will accordingly change your row settings. Okay. So see which table takes the left table. The table which you specify the first immediately after from clause is your left table, and your second table acts as your right table. So consider the position of tables in your from clause. Left joins return all matchings and non-matching rows from the left table and the matching rows from the right table. Whereas right joins returns all matchings and non-matching rows from the right table and the matching rows from the left table. Full joins returns all matching and non-matching rows from all the tables. So this is the left join and you get this output, which includes the rows from left table even if there are no matching rows in your right table. Correct? Same goes with right, and this is with full join. So before moving to this quiz, well, see, when I'm giving you this code now, take it as this code is not available for us. Hence, you can copy and save these codes. Fine. So I'm giving this code with inner join, with your left join, with your right join, and with your full join. The syntax. Take it. Go ahead. All right. So moving ahead with this quiz. Given these two select statements, look at the select statements carefully. Look at the syntax carefully. Will the result sets contain same data? What is the difference in the result sets?
This.
Understand the code carefully.
It contains same because all
No,
the
look
No,
at the
no.
yeah, look at your table carefully. Look at the
One
code carefully.
is left join, one is right join. It's not.
yes,
Yeah.
customers everything is there, and here from right join from customers everything is there, so it contains the same.
Given these two
Will the
select
result?
statements, will the result sets contain the same data? What is the difference in the result if it is the same data?
It will be the same, and matching will be common will be there.
Look at the code carefully, understand the positions of your table.
Yeah, positions are different because in first,
Position are different, but left join and right join. So that means customer is joining, all customer data is there always from customers
Yes,
file.
that is fine. Yeah.
That's what I'm saying.
So
It's
here we are using customer left join with transaction. Whereas
correct.
here you are doing transaction right join with customers. So
Correct.
the result would be like, yes, you are going to get the same, but the positions of your columns are going to be different.
yeah, that is
First positions coming from customer, it's a left join. All the rows and columns will be
From
aligned from customer to transaction. Here, the result will be right join. Of course, it will be selecting all the rows from customer because its position is to the right. But
correct.
the column position will be first transaction columns, then customer columns.
Mm.
Whereas Meena, you are correct. Absolutely. It is going to take rows from customers either which way I feel place. But the question is, yes, result is same, but what is the difference in their columns? This is the difference. Okay. So that's what it was telling. The columns are in different order. So this will be a left join, which is from customer to transaction. When it is a right join, it is transaction to customer. Result is same. See Smith Bank Jones, Smith Bank Jones. Because the position of your customer is right, your position is left. Of course, it's the same. All right. But the arrangement of your columns are different. All right.
Hmm.
So this type of questions they will ask you in your interviews. It's just checking your presence of mind.
Yeah.
Okay. All right. Okay. Now let's understand your third report. Now your third report is telling management is considering a matching spouse donation program. A report is needed showing employees who are married and make contributions to company sponsored charities. Understand the question or the scenario carefully. It is management is considering matching spouse donation program. A report is needed showing employees who are married and make contributions to company sponsored charities. So you have the data information of employee donations. You have employees with payroll. So payroll comes with employees who are donating, of course, with their salaries. Okay. And of course, their marital status. Here you have donations information. So you want the result in this form. Okay, that is all from donations matching with employee payroll. So understand this sequence or understand this scenario. Very first part of your business scenario is you have employee payroll, which contains the gender and its marital status information. So this is your employee payroll. And you have another table of donations which have employee ID and their donations, correct? So this is a part of your payroll because not all employees might be donating. Among them, few are donating, and that is also having the information about married spouses who are donating. Correct? So third part is half of all employees are married. Correct? So what we require? This part. Employees who donate to charity. Understood? Look at the diagram carefully. It's very simple. I'll show the sequence again. First part is you have a whole employee data, including their salary information, gender information, marital status information. You have a second table, which is a subset of employee data, which is donating. Hence, they are showing this small data into its center.
Okay, because it's subsetting data. Okay, got it.
Why it's subsetting? Because payroll is a huge table, right?
Mm-hmm.
So among payroll, not all might be donating. Some might be donating, some not might be donating. So you have a donation data separate, which is a part of your employee data. Understood?
Okay.
And among them, you have people who are married information. Correct?
Mm.
You may have people who are employed but unmarried, or might be divorcee, or might be with whatever their relationship is. And among them, we want only this part who are donating, who are the part of payroll, and who are married. So this is what they're telling. Correct? Who are donating, who are married. Right?
Yeah.
Yes, yes, Rashmi, I
So
understand.
to get this type of report, now you tell me which type of join you'll use. Left, right, full, inner. Payroll is your first table, suppose, and employee donations is your second table, suppose.
Second.
So will it be left or right?
Left.
Okay. So this is what the question is. For the report, you need the data for all married employees from employee payroll. You also want to include the charity names from your donations,
Mm.
which of course have employee ID in matching. What type of join should you use to combine the information from these two tables? In left, full, or none of the above?
Okay.
Okay.
Mm.
So Meena was correct, right?
Mm.
Dharni, Meena, Pragati.
Yes,
Yeah, yeah,
yes.
yeah, Ashmi.
So this is what you'll be writing. See, donations, left joined with payroll, with employee ID in common, D and P is its alias. And of course, a subsetting criteria where you want people who are only married, marital status column with M.
M. Mm.
See on clause separately on your joining criteria and where clause to subset your rows. So output order is not guaranteed unless an order by clause is requested or included. Correct? So you get the report as this. All right.
Yes.
So before moving with this, I doubt you have this code. So let's give you in your chat box. So you give this code as demo 12, okay, for this lesson, and use it when you're practicing. Or it's there on your slides. You can always take it
Yeah,
from your,
Yeah.
on PDF, right?
yes, on your PDF. Absolutely. Okay, so let's move ahead with data step merge. So it's telling a data step with merge and by statement combines tables similar to an SQL join. Columns are treated differently in the result. So customers must be sorted or indexed on your column ID before your merged can be performed. That is a prerequisite. So this is what your data step. So what happens on the basis of common column? That's what they're telling. In case, see, your columns are common, ID. Okay. So we'll not get like SQL, two columns differently. When data step, that's what it's telling. Data step merge automatically overlays same name columns. That's why you get single ID column. Correct?
Yes.
Agreed, right? So it's
Yeah.
giving you all matchings as well as non-matchings because simply writing merge by ID, you're not using any equal to dataset option to select common rows, right? But look at the common columns. ID is matching, but it appears only once. It's by default in data step, it overlays common column, but it is not the same behavior with SQL. So it do not overlay same named column. So you get this. See, are you getting it? Are you getting it? What I'm trying to
Yes.
tell you. So in this case, you can always ask SAS to overlay the common columns by using this coalesce function. So you can use coalesce function to overlay columns and it will return the values of your first non-missing argument. That means though you use coalesce function here to ID, first non-missing value will be the result and then the missing rows values will be the result on common column. Okay, that's what it's just trying to tell you. So same thing again with coalesce. See, you write the coalesce as columns in parentheses separated by comma. So it will have only one common
Yeah.
column
Columns we
and
have.
the values will be arranged because it's a common column. The values will be arranged where among the two IDs, though the values is common, which is the first non-matching or non-missing value. It will not arrange the missing value first. It will arrange the non-missing value first. Okay, that's what it's telling. Coalesce function returns the value of the first non-missing argument. That's why you get the result like this. Fine, that's it. So comparing inner joins and outer joins, limitations with inner joins, 256 rows, outer 256. Join behavior, it returns only matching rows in inner, whereas in outer returns matches as well as non-matches. Here is only one type of match in your inner join. Here you have three types of matches, left, full, right. Syntax change, you have multiple tables separated by commas in your from clause with inner join. Of course, a where clause also, which shows you a joining criteria. But here in outer join, you only has a single syntax with on clause and your joining criteria. All right, that's it. And you have an exercise. So this is the first part of your joining of your tables. So next topic would be complex joins, but this will take it later. I would request you to go ahead with this exercise as your self-study. So till now, do you have any questions, queries?
No. So this exercise on inner join, right?
It's
Or
all.
All.
It's
Okay.
all. Yes, inner join, you have a separate exercise altogether.
Inner join. Okay.
See, this was
So
about inner join. So you have two exercises. One is for inner join and one is for your outer join.
outer join. Okay.
Okay. So
Hmm.
these two topics you have separate exercises. Complex join, we'll take it in a next class.
Tomorrow, right?
which is, I think, immediately tomorrow. That is Wednesday,
Yeah.
right? Same time. Okay.
Okay.
Yes.
Any doubts, any questions?
No, not yet.
Okay, great. So please revise. In case the recordings is not been uploaded in timely fashions, I think PDF is more than enough for you for a revision. Okay, because they have given the same slides in the PDF, and of course there are some notes for every demonstration. They have explained the things. Okay, so need not to worry when you're practicing. Of course, if you have any doubts, we'll discuss it tomorrow. Fine.
Yeah.
Okay. Okay.
All right. So wish you a good day and thank you for attending this class. Bye and take care.
Thank you,
Yes.
Ashwini. Good night.
Can
Yes,
you
bye.
stop recording, Ashwin?